All right. Good morning, sugars. I hope you guys are doing good. Let's see here. We are going to learn a new lesson today. So I'm going to be kind of in and out of the classroom helping with Santa photos and doing some of that today. So I'm recording the lesson for you. So go ahead and get out your sheet of paper for your notes. Make sure you're writing everything down and let's rock and roll. I'm going to share the screen so that you guys can see exactly what I am doing. So let me go ahead and share my screen so you guys can see it. There you go. And let's see here. Let's see if we can find it. There we go. All right, so hopefully you can see this, and that gives you plenty of options to be able to see what is going on. All right, so today we are learning about logarithmic equations. So we're just going to go ahead and solve them out. This is going to be pretty easy. The first thing you have to know is that logs can't be negative. So I want you to write that down. They can't be negative. So when it says that there might be extraneous solutions or solutions that don't work, it is if you get a negative value for X, then we know that that is an extraneous solution, okay? All right, so what we need to do here is the first type that we're gonna do is log equals a log, okay? So this right here, log equals a log. And what we need to do is set one log equal to the other log. So you have the same log on the left side that you have on the right side, okay? And then what we'll do is something really, really fun happens when you have the logs set equal to each other, then you can cancel the logs. It's like they cancel each other out and then you just solve for X. So it becomes pretty easy, okay? All right, so if we can condense, then let's condense. So when it says condense, you need to make sure you have one log on each side. Okay, so take care of exponents as well. So don't forget about them, okay? All right, so here we go. On this very first one, there are no numbers in front of the log, and there's no numbers in front of that log. So I don't have to take care of exponents. So my exponents, that's the first thing I need to look for. And there are no exponents, okay? There's exactly one log on each side. So now that there's one log on each side, y'all are gonna love this. All we have to do is go whoop, whoop. And now we just solve out 5x plus 9 equals 6x. How awesome is that? Easy peasy. So let's go ahead and solve for x. And 6 minus 5 is just 1x, so x equals 9. Boom, shakalaka. Now remember, you cannot have a negative solution. So this one's looking good. We're happy with it. We're good to go. All right, this next one over here, again, you need to make sure you don't have any numbers out front that were exponents that need to be brought back. No number out front. We're good to go. They both have exactly one log on both sides. So we are going to go ahead and go whoop, whoop. And now we can just solve this out. All right, I'm going to move my 4n over this way so that my n's stay positive. All right, now make sure that you subtract, and I get a negative 42 equals 6n. So I know that n equals -7. So when I said that logs can't be negative, see where you're plugging that in, okay? Because if I plug in a -7 right there, it actually makes for a positive number here. So make sure that you pay attention to that. So the variable can be a negative, but once you plug it back in, make sure that your log is positive. So if I do that, that will be 1 minus 4 times a -7. Well, the negative and the negative give you a positive number. So you'll have 1 plus 28. And so that gives you a positive log. So this one's totally okay. And if I plugged in -7 right there, 2 times a -7 plus 43, well, that's -14 plus 43. So I still have a positive log. So this variable right there, that is okay if that's negative as long as your log stays positive. So this is a good answer. You've got to, logs can't be negative. You can have a negative solution, but not a negative log, to clarify. All right, so now I'm going to move down to number 4 because it looks a little bit different. On number 4, we actually have 2 logs on the left side with a plus sign in the middle. And we know if I'm trying to condense that plus signs and multiplication go together. So look back at those notes. So I'm going to rewrite the log one time. And then I know that I actually have to multiply each one of these numbers together. Okay. So it doesn't matter which order you do it in. So I'm going to put 4 times y plus 5. I'm going to have to multiply those together. And then there's nothing to do on the right side. So now that I have exactly 1 log on the left and 1 log on the right, I can cancel those logs out. And now I can solve this equation. So distribute. Now solve. And divide by 4, and you get y equals 13. Now look at it. If you were to plug 13 back in there, you'd still get a positive log. So you're good there. Okay. All right. So let's keep moving on, see what we come up with. Right here, number 5. So remember what I said at the very beginning. I said to look for exponents, and that means there's a number out front that needs to become the exponent. Okay. So this one has a 3 out front that I need to move. This one on the right doesn't have anything, so it's good to go. So when I rewrite this, it'll be log base 7 of 4 to the 3rd power. And then I have log base 7 of 4a minus 8. Nothing wrong with the right side. I just had to condense the left side. All right, so 4 to the 3rd, that's log base 7 of 64. So 4 to the 3rd is 64. And then nothing is going on the right side. Now that I have exactly 1 log on the left, 1 log on the right, I can cancel them. So I have 64 equals 4a minus 8. So I'm going to add 8 and add 8. And I get 72 equals 4a. So a equals 18. There you go. All right, so not too bad. Let's come down and do number 8 because it's kind of a bad mamma jamma. Okay. All right, so on number 8, look on the left side. There is no exponent that needs to be taken care of. There's no number out front that I need to bring up front or up to the top as the exponent. But on the right side, I have 2 logs and I have an exponent on the front, a number right there that needs to be moved into the exponent. So I actually have 2 different things to do. You always take care of exponents first. So I'm going to move that 2 up to the tippy top. So it'll be log base 3 of 6 squared minus log base 3 of 4. And now this minus sign in the middle, this minus sign means to divide. Remember, when you're trying to condense, I have 2 logs, but I need to change it to 1 log. So that means that I rewrite 1 log, do my parentheses, and I have to divide these 2 numbers. So 6 squared is 36 divided by 4. And then on the left side, So now I can, now that I have exactly one log on the left and one log on the right, they cancel each other out. And I have 2p minus 5 equals, what is 36 divided by 4? 9. So add 5. You get 14. So p equals 7. Always check. Let's come back around. And if I were to put a 7 in there, that's 2 times 7 is 14 minus 5. So yes, that absolutely works. We are good to go. All right. Okay, if you want to see the rest of these, you can look at the video on Google Classroom to have some extra practice, which would be good for the test, okay? All right, so now we're gonna move on. Let's go, let's look at maybe number 10, because it kind of gets a little crazy, and so does number 9. Both of these are good examples, and it doesn't really matter which one I do. I think I'm gonna do number 9. All right, so number 9, I have exactly one log on the left and one log on the right. And if I look at the left, there are no numbers to be moved into the exponent. There's already an exponent, but there's no numbers to be moved there. So that's good. And on the right, there are no exponents. So it's good to go. So now all I have to do is cancel, cancel, and rewrite. M squared equals 18 minus 7m. Now, y'all, there are 2 types of m's there. And there are 3 terms. So this is going to end up being a trinomial. And I should have 2 solutions because there is an x squared. So I should have 2 solutions. In this case, since it's a squared value, you need to set it equal to 0. So what I'm going to do is I'm going to move my 18 over and my 7m over. I'm going to add 7m and add 7m. So now I'm just going to take all this and I'm going to put it in the trinomial order. Okay, descending order. M squared plus 7m minus 18 equals, there's nothing left over here, so 0. All right, our favorite thing, this is a shortcut factoring because my a value is 1. So I can come over here and do a quick X method. What multiplies to give me a negative 18 and adds to give me 7. So I'm looking at 9 and 2. Looks like I need to make 2 negative. So now I'm going to take those 2 numbers. Since it's the shortcut, I don't have to do factor by grouping. And I can just put the 9 right here and the negative 2 right here. So my answers are m equals negative 9 and m equals 2. Now check them both. So if I put a negative 9 up there, it would square and become a positive 81. So that negative 9 is okay. If I come over here and put a negative 9, it would be negative 7 times negative 9, which gives you a positive 63. So we're good to go with that negative number, okay? So this one's good. And if I were to put a 2 in either one of those, that would still work. 2 squared is 4. You can take the log of 4. If I put a 2 in there, that would be 7 times 2. That would give me a minus 14. 18 minus 14, still a positive number. Both of those work. The answer for this one is k equals negative 4 and k equals a positive 4 if you'd like to work it out and pause the video, okay? All right, our second type is if the log equals the number, okay? So now it's not log equals a log. We have to do log equals a number. So first we're gonna condense and isolate the logarithm. Condensing, no problem. Isolate just means put it on one side. And then we're gonna rewrite it in exponential form and then solve it out, okay? So don't forget your exponential form. So if you have log base b of m equals x, that is the same thing as b to the x equals m, okay? So just remember it's that up and swap or the drop and swap, okay? We're gonna be doing the up and swap. So you are doing the up and then the swap. So the B moves up, so you're doing the up and swap. Okay, so first make sure you've condensed. So condensing means you need to look for exponents and you need to have exactly one log. Okay, all right, so on this one, we have exactly one log. There is no exponent in front of that log base 2, so we're good to go. So the next thing is put it in exponential form. So the base right here moves up and becomes the base of the exponent, and then you have to swap these two. So it will be 2 to the 6th power equals x minus 4. So let's go ahead and figure out what 2 to the 6th power is. It's 64. So 2 to the 6 is 64 equals x minus 4. Add 4, and you get x equals 68. Okay. All right. On number 12, first you have to isolate the logarithm and look for exponents. Right now, there is no exponent in front of that, but I do have this random -7 that's not a part of the logarithm hanging out on the back side. So I need to isolate the log as much as possible. So I'm going to add 7 and get the log all by itself. So now we have 4 log base 3 of 4x plus 8. Now the log is all by itself, okay? It's just the log of that number, that big old number. So now I can rewrite this in exponential form. So up and swap. So the 3 moves up, the 4 goes on the 3, and then you swap and the 4x plus 8 goes to the other side. So we're going to figure out what 3 to the 4th is. 81. So I have 81 equals 4x plus 8. Subtract 8, subtract 8. 81 minus 8 is 73. Divide by 4, divide by 4, and your answer ends up being 73/4. I don't think that reduces. It's okay to have a fraction in there. So if you were to plug that back in, 4 times that fraction plus 8 is still a positive number. So it is good to go. All right, number 13. Let's look at number 13 and see how we go about number 13. Okay. All right, so no exponents out front, but I have 2 logs and I have to condense it to a single logarithm. So this addition sign right there will become multiplication. So you rewrite the log one time and you're going to multiply 2x times x minus 5. Do your parentheses and 2x times x minus 5. Well, what do y'all think I need to do right there? I need to go ahead and distribute. Okay, so I'm going to distribute. And all right, so I have log, and what is the log? What is the base of this log? Since it's not there, we know it's a 10. So I'm going to go ahead and distribute, and I get 2x squared minus 10x equals 2. All right, so now that I have this as a single log, even though it's ugly, okay, even though it's ugly, I can still rewrite it. So base moves up and these two swap. So I have 10 squared, because remember you're swapping these, equals 2x squared minus 10x. Well, we know what 10 squared is. That's 100. And I do have an x squared and an x and a number. I have 3 terms. So that is trinomial. So I'm going to subtract this 100 over, put it on the other side. And I have 2x squared minus 10x minus 100. All right, what do you think I have to do with that? I can do the x. Okay, I'm going to come over here to the side so I have enough room. 2x squared minus 10x minus 100. All right, and what I'm going to do is I'm going to go ahead and take a 2 out front, and then I can use the shortcut x. So if I factor a 2 out front, then I'll have x squared minus 5x minus 50. And now go ahead and do the x on this. What multiplies to give you a negative 50 and adds to give you a negative 5. So I know it's 10 and 5 somehow. It's going to have to be a negative 10. So negative 10 plus 5 gives you a negative 5. So these are my two numbers. So the 2 still out front. And I have x minus 10 and x plus 5. All right, still set equal to 0. All of this is set equal to 0 from the problem over here. And now you set them all equal to 0. So you have 0 equals 2, 0 equals x minus 10, and 0 equals x plus 5. Well, that doesn't make sense, so it just goes away. Solve this one out, and you get x equals 10. Solve this one out, you get x equals a negative 5. Now check both of your answers. If I were to plug a 10 in here, that would work. 10 minus 5, that's a positive number. 2 times 10, that's a positive number. Plug a negative 5 in. 2 times negative 5. Would that work if I plug the negative 5 in right there? 2 times negative 5. No, because you would get a negative 10 and you can't take the log of a negative number. Okay, same thing here. If I put the negative 5 in right there, that would give me the log of negative 10, and that does not work. So this one right there, that is extraneous. So just put extra. Okay. All right, I think you're doing good. Let's do number 14 and then we'll be done, okay? This one's a little odd just because it has a fraction, but it is not difficult at all, okay? But you're gonna have to think just a hair on this one. All right, so remember, I need to condense. I have 2 logs here and I just need 1 log. Look at this first log. I have a 2 on it, so that 2 needs to move up and be the exponent on the x, okay? So the first thing I'm gonna do is I'm going to move that 2 up to just this log. It doesn't have anything to do with the log of 4. So this is log of x squared minus log of 4 equals 2. Now this minus symbol in the middle when you're trying to condense becomes division. So I have rewrite the log. I'm going to put a base 10 on it. And these two numbers have to be divided now to rewrite it as 1 log. So I have x squared all over 4 equals 2. That looks funky, but it's really not that bad. Do I have exactly 1 log here? Is everything condensed? Absolutely. So now I can rewrite it in exponential form. So remember, this base moves up and swaps. So 10, swap these two, and it'll be 10 squared. 10 and squared, the 2 comes from over there, equals, and then this moves to the other side. So it's x squared over 4. All right, let's finish. What's 10 squared equal? 100. So I have 100 equals x squared over 4. I need to get x by itself. So I need to multiply by 4 on both sides. Wild, yes. And there's only an x squared here. So 4 times 100 is 400 equals x squared. Now you could set this equal to 0, but since there's only one x, I can just use a square root and square root that. And I know I get 2 answers from square rooting. So we're going to do the square root of 400. And you get plus or minus 20. Now, it does look like a positive 20 would work if I plug the 20 in right there, but the negative 20 would not work. Realize that this is 2 answers. That's 20, and it is also negative 20, plus or minus 20. That's 2 different answers. The negative 20 wouldn't work because you can't take the log of a negative number. So mark that out, and the negative 20 does not work, okay? It is extraneous. All right, y'all, I'm going to go ahead and write down the two answers for 15 and 16 if you'd like to try them on your own. So this would be a factoring problem. You have x equals -12 and x equals 3. This one should be extraneous. And the answers for 16, x equals 5 and x equals a -2. And this one comes out to be extraneous as well. So if you need some extra examples, you can definitely either watch the video from the lady that I'll post today, or you can try those on your own and see if you get that, okay? All right, let's see what we have going on here. All right, so hope you guys, hope you got all that. Hope it is okay. And I appreciate you guys understanding that I had to teach a video lesson today because we are trying to raise money for Caring Christmas and adopting a family. So it's for a good cause. So I appreciate you guys handling yourselves well. And now I want you to move on and get your homework done. Okay. So I know you can do it. I think you can do it on your own. And I want you to try hard and use your notes, use your brain. God gave you that brain for a reason. And I know that he wants you to use it. Okay. All right. Guys, I appreciate you and I hope you have an awesome day. Bye.